Look around you for a moment. The Earth beneath your feet is spinning at over 1,600 kilometers per hour. The Moon is rotating, the Sun is spinning. Our galaxy is twisting like a giant cosmic storm, and even atoms deep inside your body are constantly in motion. Everything in the universe seems to be spinning. But the most important question is not that it spins. The real mystery is this: where did the very first spin come from? Who gave the universe its original momentum when nothing existed before it? To understand this, we must first understand what spinning actually means in physics. Scientists call it angular momentum. It is the energy of rotation, and it is one of the most strictly protected quantities in the entire universe. According to the law of conservation of angular momentum, once something starts rotating, it will never stop unless an outside force slows it down. This law works for a child's spinning top, for planets, for stars, and even for invisible particles. Once rotation is born, the universe never lets it die. Now we reach the deepest part of the mystery. Where did the first angular momentum come from if everything began with the Big Bang? Many people imagine the Big Bang as a giant explosion in empty space, but that is not accurate. The Big Bang was the sudden expansion of space itself. In the very first fraction of a second, the universe was unimaginably hot, dense, and energetic. But most importantly, it was not perfectly smooth. Tiny quantum fluctuations existed, microscopic, uneven patches of energy that appeared randomly due to the laws of quantum physics. These tiny irregularities are the true birthplace of motion. When the universe expanded, matter rushed outward in every direction. But because of those tiny imperfections, the flow was never perfectly balanced. Some particles collided slightly off-center, some streams of energy moved sideways instead of straight, and this created the first microscopic rotations. That was the birth of angular momentum. No giant hand pushed the universe. Spin emerged naturally from chaos and imbalance at the very beginning of time. Once this first rotation appeared, the law of conservation locked it in forever. From that moment onward, the universe was doomed in a beautiful way to spin eternally. Even when matter spread out, even when stars formed and died, even as galaxies collided, the total amount of angular momentum never disappeared. It only changed form, transferred, and multiplied across cosmic structures. As the universe expanded and cooled, gravity began pulling matter into massive clouds of gas and dust. These clouds were not motionless. They already carried tiny leftover rotations from the early universe. As gravity squeezed them inward, something powerful happened. When an object shrinks in size, its rotation speed increases. Just like a figure skater spins faster when pulling in their arms, these collapsing clouds began to spin faster and faster. This is how stars were born spinning. The leftover material flattened into spinning disks, which later formed planets, moons, and entire solar systems, all rotating for the same reason. This is why planets orbit stars instead of falling straight into them. This is why Earth rotates instead of standing still. This is why the Moon circles our planet with perfect rhythm. None of this required a new force to start it. The universe is still using the same ancient momentum that was created in its first moments. The same principle works on a much larger scale with galaxies. Entire galaxies spin because the matter inside them never lost its original angular momentum. Over billions of years, countless stars formed inside rotating clouds, and their combined motion produced massive rotating systems. Even dark matter, which we cannot see directly, carries angular momentum and plays a huge role in controlling how fast galaxies spin without flying apart. Every spiral galaxy you see through a telescope is proof that the universe has been spinning continuously for over 13 billion years. Spin does not exist only in giant cosmic objects. It exists at the smallest possible scale. Inside every atom, electrons spin. Even fundamental particles that do not physically rotate behave as if they are spinning due to the laws of quantum mechanics. This tells us something profound. Rotation is not just a feature of stars and planets. It is built into the deepest structure of reality itself. The universe was born rotating, and every level of existence still remembers that motion. On Earth, spinning objects eventually slow down because of friction and air resistance. But in space, there is almost no friction. That means once something starts moving, it can continue for billions of years without stopping. This is why Earth still spins after 4.5 billion years. This is why planets keep orbiting. This is why galaxies remain in motion across unimaginable distances. The universe is the closest thing to a perfect motion-preserving system that nature can create. Some people then ask a deeper, more philosophical question. If quantum fluctuations created the first imbalance, then why did those fluctuations exist at all? Was it pure chance? Is randomness built into reality itself? Or does some deeper law exist beyond what we currently understand? Science can explain how motion began, but the ultimate why still remains one of the greatest unsolved mysteries of existence. What we do know is this. Everything in the universe spins because motion was born in the first imperfect moment of creation. Tiny quantum imbalances created the first rotation. Gravity amplified that motion into stars and planets. The law of conservation protected it across time. And friction, which slows motion on Earth, is almost absent in space, allowing spin to continue nearly forever. Every rotating galaxy, every orbiting planet, every spinning atom inside your body is carrying the same ancient momentum that was born at the dawn of time.